This video is for Chapter 10, Section 7, and it's all about the area of circles and sectors of circles, which are kind of like pizza wedges. So we're going to start off with the area of a circle, and a quick slide here that just talks about where the area of a circle from a formula, where we might be able to see it come from at a basic geometry level. So here I have a bunch of sectors of a circle. I divided this circle into 16 equal parts. Now every time we divide it into equal parts, they get even smaller. But if you check this out, I'm going to take this sector off and I'm going to put them all here in a row where I switch them back and forth. One is up, then down, up, down, up, down. It's kind of hard to see, but hopefully you can see the pizza wedge right here, and then another wedge, and I keep flipping them over. What you notice that the wedges all come together and they start to look like a parallelogram. If we actually divided it into even smaller wedges, it would get closer and closer to being flat along here and straight or perpendicular here. Now, since half the wedges are facing this way, half of the crust is here, and so this is the base of the parallelogram, and it has a length of 1/2 the circumference. And eventually the height of the parallelogram, or perpendicular to this distance, would be the radius of the circle. So if we actually use the parallelogram, area equals base times height, our base is 1/2 circumference, 1/2 of 2 pi r, and then we can say our height is equal to r. So I can reduce my base 1/2 2 pi r to just pi r, and my height is r. Now let's substitute those right here, and I've got area equals pi r base times height, r. Pi r times r. Pi r squared. So this was just a little side note of where pi r squared came from, and how we discovered the area formula for a circle. Let's move on to sectors. Now, sectors of a circle represent a fraction of the circle, just like arc length, but now we're talking about the area of a circle. So in this picture right here, this green portion is a sector. The gray portion is also a sector. So it is the region bounded by two radii, 1, 2, and their arc. Okay, the green area is a sector, the gray area is a sector. So simply, the area of a sector is just the fraction of the circle's area. If we had half a circle, we would just take the area of the circle and divide by 2. If we had 1/4 of a circle, area divided by 4. So we're going to use this to do almost the exact same equation as arc length. The area of sector AOB, now we're going to talk about the green sector here. Angle AOB is going to be the measure of arc AB divided by 360. That becomes the fraction of the circle. If it was 90 degrees out of 360, that would be 1/4 of the circle. If it was 180 degrees out of 360, that would be 1/2 the circle. Fraction times pi r squared. In our previous lesson, it was fraction times 2 pi r. That's arc length. This is now sector area. Fraction times area. So what if we did this example here where x is equal to 135 degrees and the radius is going to be 8 inches. So to find my sector area, okay, and my sector area is going to be for AOB, the first part, AOB's area, I would take 135 over 360, and I would multiply that by pi r squared, so 8 squared. Now, it is important that we reduce this fraction to help us understand. Using our calculator or our mental math, we can reduce this to 3/8 times 64, that's 8 squared, pi. Now we're going to put that over 1 so that we can reduce the fraction. 64 reduces with 8 to become an 8. 3 times 8 becomes 24 pi. And 24 pi inches squared becomes the area of the green sector. Now we also said, what about ACB, which is the gray sector? Well, there's two ways to think of it. At this point, we know that the whole area is 64 pi, and we know that the green part is 24 pi. So with a little subtraction, if you take the whole and subtract the green, you get the gray at 40 pi inches squared. Now we could have done that the gray represented the other 5/8 of this circle. So sectors, fraction times area. And the fraction is the arc measure divided by 360. These equations are very, very close to each other, so it's very important that we study and understand the arc length and sector area formulas. Arc divided by 360 gives us the fraction times pi r squared. Okay, so now we're going to look at what's called a segment of a circle. Now a segment of a circle is this orange part right here. Okay, it represents the part of a circle bound by an arc and the segment that connects the two arcs' endpoints. So here's the arc, and here's a straight line connecting them. A lot of people see the segment section of a circle like this. They see it as a sector, and then we punch out the triangle, and we're left with a segment. Well, we just learned how to find the sector area by using fraction of the circle times pi r squared. We know how to find the area of a triangle, 1/2 base times height. So, sector minus triangle equals segment. These are important notes. I will do examples in class. We will spend a lot of time on this. But you need to have these notes down so that the examples can be done in class. Now, look beyond this. Let's see if we can go. Sometimes we can find a sector area, or not a sector area, sorry, this should say segment. We should find a segment area by subtracting an inscribed shape. Check this picture out. Oh, let's see if we can get outside this here. What if I needed to find that orange segments? Well, let's think theoretically here. We could just take the area of the circle and subtract the hexagon. Find the area of the circle and subtract the hexagon. Now that would give me all the parts in orange. If I wanted just one of the orange parts, I could just divide by 6. And that would give me one orange segment. So sometimes we can find segment area by subtracting an inscribed shape. Circle minus hexagon gives us all of these parts. Divide by 6 and you get one part. Let's look at some examples. Okay, so up at the top we have our first example. This is the pizza example. The radius of a medium pizza is 10 inches and the radius of a large pizza is 12 inches. How much more pizza comes with the large? You think it's only 2 inches bigger. How much more pizza? Well, the medium area is equal to pi times the radius squared, and the radius is 10 inches squared. So that's 100 pi. The area of the large is equal to pi times 12 inches for a radius, which is 144 pi. So how much more pizza do we get with the large? Well, 144 pi minus 100 pi, we end up getting 44 pi. That's quite a bit. That's almost another half of a pizza. If the medium was a 100 pi, 50 pi would be another half. So just by adding 2 inches, we almost get another half of a pizza. And if we wanted to, we could always convert this using our calculator. 44 times pi as a decimal would be 138 square inches of pizza. You get another 138 square inches of pizza. That's good stuff. All right, let's go to D. Find the area of the orange sector. Exact answer. I like exact answers. So this is going to be the orange. So we have to find the fraction of the circle. I know this is 144. I need this one's measure. So I start by saying 360 minus 144. We go through and we say 360 minus 144, which is 216. And now we can go, what is 216 out of 360? Okay. And we're going to try to figure out what fraction this is of pi r squared. And my radius is 5. Now this problem comes out, we've got 5 squared, that's 25. If I reduce this fraction, 216 over 360, with the calculator, what? It comes out to 3/5 times 25 pi. Put the 25 over 1, so we can reduce the 5 with the 25. 3 times 5 equals 15 pi. And what's this? Feet squared. That right there is an exact answer because it's in terms of pi. Let's continue with these examples. Let's go up here to do the blue segment here. So remember, we're going to do sector minus triangle equals segment. Okay, so sector minus triangle equals segment. The sector is 90 degrees out of 360, which is 1/4 of pi times 6 squared. So 1/4 of 36 pi is equal to 9 pi. And then we have a triangle, which is 1/2 base times height. Well, the base and height are radii of the circle. It's a right triangle. That works nicely for us. We get 1/2 of 6 times 6. 6 times 6 is 36. Half of that is 18. This right here is the exact answer, meters squared. Because I don't know what 9 pi is. If I want the rounded answer, I'm going to take on my calculator 9 times pi, which is about 28.27, and subtract that 18. And I get approximately 10.3. So this is exact, this is rounded. Again, exact and rounded. As we look at the final example, we will end up doing this example in class. Okay, you can try this one on your own if you'd like and see what you come up with. Find the area of the green sector. Okay, so the green one here, you can try to find this value here. It comes out as a fraction. Okay. And then there's also, try to find the red segment. Now this one is very difficult. That's why we're going to do it in class. You're going to have to take the area of the sector and minus a triangle that is not a right triangle. There are going to be 2 or 3 different ways that we can do this, and that's why we'll do this example in class. For now, you have the notes and 3 basic examples that will really get us started on the work. We will do more examples in class, and then you will be able to do assignment 7. That's it for chapter 10, section 7 about area of circles and sectors.